This is solving compound inequalities. When we look at this, there are two types. And so remember, as I go through this, annotate your notes. Put some words in there so you see where everything is coming from. We have two types. We have the ones that have and we have ones that have or. So those are our two types. First, we're going to start with and. It's true if both inequalities are true, and the graph is the intersection or the overlap. Okay, an example would be if you're driving on the turnpike. You have to be going less than or equal to 75 miles an hour. But you also have to be going greater than or equal to 50. So you can't just be doing less than 75 or greater than 50. You have to be between the two. So you have to be both. That's an example of and. Let's look at the first one. So of course, knowing what an and inequality is, that's going to be one of the questions. And the next one here is how can you break up this inequality? As I look at it, I have two different inequality symbols. So I'm going to show you how to split that up, and that's also going to be a quiz question. When you split this up, what you want to remember is that what's in between the inequalities, which is the x minus 3, that's part of both. That's a good thing to write down. That's a good thing to annotate. So it's part of both. That's part of both. Okay, so my inequalities, one of them will be here all the way to the end. So that's negative 2 x minus 3. The other one is here to the end. But notice x minus 3 is part of both inequalities. Okay, then you just solve it. So I'm going to add 3. Okay, so I have that solved. Now I'm going to graph. Okay, so you're going to graph each of these individually. So I'm looking at this one, and here's 1. It could be equal to, so I fill it in. It's pointing at the number, so I'm going to go to the right. Here, it cannot be equal to. Pointing at the variable, so it's going to go left. So here is my graph. It's between these two numbers, including 1. 1 is a possible answer. Everything else is a possible answer up to 7, which is not. Okay, looking at number 2. These are already split up, so all I need to do is graph them. Or I need to solve, then graph. So I'm going to add 3. Pay close attention to negative numbers and placement. Negative 8 is left of the number line of negative 5, but a lot of people will get that wrong, so make sure you pay attention to that. So this one, it could be equal to. This one, it can be equal to. So y is greater than that and less than that. So it looks like this. Everything in between, including negative 8 and negative 5. Okay, let's look at compound inequalities with or. It's true if one of the inequalities is true, and the graph is the union. Okay, so make sure you know what is an or inequality. Also, you need to know within is inclusive. So within means it's going to be filled in. Between is exclusive, not filled in. Of course, a real life example would be you can play on the basketball team, or whatever team, if you're in the 8th grade or 14 years old. You don't need to be both. You just need to be one or the other. And that's an or inequality. So here's an or inequality. Nope, that's 37. And typically you won't need to break these up, you just need to solve. So hopefully you remember how to solve these. I'm going to subtract 7 on both sides. Then I need to divide by a -2. Watch out, remember this, I'm dividing both sides by negative number. So I reversed that inequality. That's a good thing to annotate right there. I reversed it because I divided both sides by a negative. Okay, so those are my two inequalities to graph. So if you struggle graphing these, just graph one at a time. Forget about looking at this one. So I'm just doing m is greater than -3 or equal to. It can be equal to. So it goes like this. Greater than 5 looks like this. Okay, sometimes, this is not the common one, but sometimes you get where both of them are pointing in the same direction. If that's the case, this inequality, this graph, is not necessary because it only needs to be one of these. Anything that's greater than 5, of course, is going to be greater than -3. So you don't need to graph that. And when you see the answers in the book, you'll probably only see this because these are all included as something that's already greater than -3. Let's look at the last example. I have a plus 1 is less than 4, a minus 1 greater than or equal to 3. To solve, subtract 1 on each side. A is less than 3. Over here I have to add 1. So it looks like that. Remember, pause this if you need to slow it down. Now I'm going to graph. Just pay attention to one at a time. So I have a is less than 3. That looks like this. Make sure you come in and ask for help if you're struggling with the graphing. And a is greater than or equal to 4. This is typically what your graph will look like for an inequality that is OR. Make sure to take the Edmodo quiz. Make sure when you bring your notes into class, they are annotated. I can see words written for each one of these so that you know where the numbers are coming from.